Hello viewers, welcome back to another section of our tutorial channel, and in this video we are going to talk about delta star transformation. One may ask, is it possible for resistors not to be in series and also not to be in parallel? Yes. So two resistors may not be in series, so they will neither be in series nor also parallel. Then what would they be? That's the question, and that is what we are going to talk about in this video. Kindly watch this video to the end, don't miss any part of it, and kindly subscribe if this is the first time you are visiting this channel. So delta star transformation, I have this circuit here to demonstrate delta star transformation. So we have our voltage source here. I have 5 resistors. Now let's see resistor 1, resistor 2, resistor 3. If I take 2 resistors at a time, that is resistor 1 and resistor 2, you realize that there is a node here, yes, but when I traverse through them, they are not in parallel. So R1 and R2 are not in parallel, and since there is a node, they are also not in series. When I take R2 and R3, there is a node, hence they are not in series. When I traverse through them, you realize that they are also not in parallel, and likewise for R1 and R3. So in this scenario, R1, R2, R3 are said not to be in series and also not to be in parallel. So that is where we introduce a system called delta or star transformation to solve this problem. Hence, these two resistors are said to be in delta. Now I'm going to show you the difference between delta and also a star. So let's see another scenario. We have this, and finally we have this. So R1, R2, R3. So these two resistors also are meeting at this common point here, and since there is a node between any two of them, they will not be in series and they can't be in parallel. For that reason, this is what we call a star because of how the shape looks like. Then we have the similar one we did situation where we'll be getting this. So in this case we call it delta. There will be a node here, then probably maybe here, but the arrangement we call it delta. So take note, the delta can also be this way, that is a triangular form, this way. So this star and this is delta, or this is also delta. So that is delta star concept. Now we are going to look at how we are going to simplify delta star transformations. When you are given a circuit where you have a delta or star, how do we go by it, and what is even the transformation? So now let's see. Assuming I have a star and I want to send it to delta. So see, I have this resistor RA, I have here resistor RB, I have here resistor RC. It's in star. To compute this or to find the total resistance, we can only do that by converting it to delta. And how do we do that? I told you that delta can be in triangular form and can also be in what? The square or the rectangular form. Hence, to convert this easily to delta, we are going to introduce new 3 resistors. That is, we are going to transform these resistors to the delta. Hence, we introduce this branch here, another branch here, then another branch somewhere here to cover the 3 sections. Then we call here R1, we call here R2, we call here R3. So now you realize that the R1, R2, R3 is now the delta transformation, and the inside one is the star. So we are trying to convert the star we have here to the delta, and that is exactly what you are doing. To do that, you are going to first close the branches of the star with new branches, make it delta. Then you find the corresponding values for R1, R2, then R3. So let's see how we are going to do it. So whenever you do this, the value for R1 will simply be equal to the two resistors you closed with a branch, that is RA and RB, you add them. So RA plus RB, then plus their products, RA, RB, sorry, RA, then RB. So let me write it. So I'm going to have my R1 to be equal to RA plus RB plus RA, RB all over R this one, so all over the opposite branch, that is RC. So whenever you are finding the equivalent transformation in delta, this delta branch is covering 2 and this is the focus. You add these two, then you find your product over the opposite one, that is RC. And now let's do that same for R2. R2 becomes RB plus RC plus RB, RC all over what? The opposite RA. And it's continuous for R3 which is equal to, so RA, RC all over what? RB. RA, RC plus RA, RC all over RB. And that is a transformation from from star to delta. So when you get these values, you clean your star within and it will turn to delta. Now let's see from delta to star. So from delta to star, you already have this, and here is my R1, here is my R2, here is my R3. So to convert this delta to star, I need to draw my star within. Then take note, each star branch will fix between two delta branches. So I have these two resistors, R2 and R3. One will enter here, and one will enter. Here is my RA, my RB, and my RC. That will be my star values. How do I get my RA, RB, and RC? My RA is simply equal to, the RA finds itself between R2 and R1. So you multiply them. So you are going to get R1 multiplying R2 all over the sum of the 3. And that is the formula, R1 plus R2 plus R3. Likewise, our RB will be equal to, is found between R1 and R3. So R1 times R3 all over R1 plus R2 plus R3. This formula seems more simpler than the star to delta. So finally our RC will be equal to, is between R2 and R3. So R2 times R3 all over R1 plus R2 plus R3. And that gives us our delta to star transformation. Now, let's take a question and see how we solve this. So I have a problem here. Determine the total resistance of the circuit below. Now let me draw the circuit. I have point A, and it will come down like this, like this. Here's my point B, point A. So here it's given by 6 ohms, here it's given by 3 ohms, 6 ohms, then 6 ohms, then 3 ohms. So the question is, determine the total resistance of this circuit below here. And to find the total resistance, we need to check resistors in series and resistors in parallel. And now we need to check resistors which are in delta as well as which are in star. So let me see. When I take any two here, you realize that these resistors are in delta. There is a node here making none of them in series. When you traverse them, you surely meet the other one. Hence, these three resistors here, we can't get series or parallel connection from it. Hence, we are going to apply the delta star. So now, how do we do the transformation? So see, the first step is to transform. This one too is a delta. I have 3, 3, and 6 in this form is a delta. We need to transform any of them to star before we proceed. So let's transform this to star and see how we are going to do it. So I have this up here, then coming down to this, So let's see. And when you are simplifying circuit network, the most important thing is for you to redraw. And this is 3 ohm, this is 6 ohm, 6 ohm, 6 ohm. So my A and B. So the first thing is to introduce your star. So one star is in between this and this one and this one. The other star two will be in between here, and the final one will be here. So I'll call this A, I'll call this B, and I'll call this C. I'm transforming the delta to star. So what am I supposed to do? I'm to find the value for A, B, and C. Then I clean the delta aspect. So when I find A, what is A giving me? A will simply be equal to 6 times 6. Remember, it's from delta to star. You multiply the resistor in which the star is between. So 6 times 6 all over the sum of the three resistors, which is 6 plus 6 plus 6. This is giving me 6 is 36. This will give me 18, and the answer is 2 ohm. That is for resistor A. For resistor B, since they are all 6, 6, you surely get 6 times 6 over 6 plus 6 plus 6, and that will give us 2 ohm. And there is a rule that whenever you are using delta star and you are converting from delta to star, and all the resistors are equal, then you simply divide each resistor by 3. So resistor by 3 to get the star. And if it is star to delta, you multiply it by 3, provided all the resistors are of the same magnitude. So R1, that is resistor in delta over 3, will give us in star. Then 3 times resistor in star will give us delta. So now this is our first step, and we had each values for A and B and C to be what? 2. So let me clean this side. So now, since we know that all the values are 2, we are going to redraw again, and in this time we are going to have C. We are going to draw the star, not the delta. So to draw the star, I have my A, and this is the center, and this is the B, and it will come down like this. Then the C2 will come, it will join this to this, right? Here is gone, the other place too is gone. So this will join straight to the A terminal. We are drawing this. Here is 2 ohm, 2 ohm, then 2 ohm. Here from our question is also part of the delta. So sorry, I need to clean that one too. So this branch is not there. We are only left with the C here, like this, and it will come straight. So let's see. It will come, this place will come straight to the 3 because the node has been removed. This will also come straight to the 3 ohm, 3 ohm, and we'll join here to the B. At this point, I think the simplification is simpler. I can see these to be in series, right? So let's solve that. So we are going to get our resistor our terminal A here, moving to 2 ohms here, right? Then this place will combine to be 5. When they are in series, you just add them. So I'll get my 5 ohm here. Then this one will also move into 2 ohm. Then it will come here, 3 ohm. Then this one will move to B. So you can see clearly that the 2 ohm here and the 3 ohm are also in series. Hence, I redraw and I get my terminal A moving straight to the 2 ohm, to this 5 ohm, then also to this 5 ohm. This will give to B. And at this point, 5 and 5 are clearly in parallel. When I traverse through them, they are the only two resistors I see. Then there's a node, there's a node. So they are parallel. Hence, parallel combination will be 5 times 5 over 5 plus 5. That will give me 25 over 10 equal to 2.5. Hence, I get from A, I'll get my 2 ohm. Then I'll get my 2.5 ohm. Then it will move to B. So now I can clearly see that I have 2 ohm and 2.5 ohm in series. So my total resistance becomes 2 ohm plus 2.5 ohms and is equal to 4.5 ohms. Thank you for joining me for this section. Hope seeing you in the subsequent videos where we'll be treating the Norton's theorem, the Thevenin's and other theorems.